Now we're going to look at the distance function. So the function a gives the distance of x from 0 on a number line. So we're going to complete the table. So if x, if our input is x, or if our input is 8, 8 is 8 spots from 0. If it was our output is 5.6, our input would be 5.6. We could also have negative 5.6 here because that would give us an output of 5.6 as well. If our input was pi, pi is pi spots from 0. If our input was 1/2, our output would be 1/2. If our output was 1, we could have two inputs, either 1 or negative 1. If our input was 0, 0 is 0 spots from 0. If our input was negative 1/2, our output would be 1/2. If our input was negative 1, our output would be 1. If our input was negative 5, or negative 5.6 is 5.6 spots from 0, so our output would be 5.6. If the number that's 8 spots from 0, we could have positive 8 or negative 8. So I'm going to add those spots. So if we were to graph that, this just becomes that absolute value function. So we have 0, 1, 2, 3. The absolute value of 1 is 1. And if I put in negative 1 here, it just makes that familiar V shape. Now, there's a few things that we can notice and bring together about this. Andre could write this as a piecewise function. So Andre wrote the function a of x is equal to x if x is greater than or equal to 0. So if you notice, this is a function y equals x, or the line y equals x. And then a of x could be negative x. This line is the function y equals negative x. And we could do that if x is less than 0. So you can write the absolute value function as a piecewise function. So to explain why that's true, the piecewise function also correctly describes the absolute value function. So the piecewise function is the same graph as the absolute value function.